Muy bien. Buenas tardes a todos. Hoy tenemos con nosotros a Mark Horvath de Causality Group, un grupo de trading propietario que patrocina RoboTrader y por el cual estoy muy agradecido. Y hoy su promotor, Mark Horvath, nos va a hablar de la aplicación de los modelos grandes del lenguaje a las finanzas cuantitativas. Así que, Mark, cuando quieras, puedes empezar.
Thank you, Eduardo. Thank you for the opportunity. I'm going to speak in English, but anytime if you don't understand something, feel free to interrupt. I speak Spanish, but as we know, the language of money is English, so I'm trying to use that. I'm going to speak about how to build an LLM agent today. It's going to be introductory. So I'm going to assume basic understanding of what the language model is. But other than that, I'm going to show basic techniques to customize a single LLM agent. I'm going to show you a multi-agent LLM framework where you could build chat rooms and complex interactions between agents. That I would say it's level 2. Right now, I want to focus on simple or not so simple techniques to actually make your agent a bit smarter than just a plain language model coming out of training. It's the moment that I would like to say thank you to our team as well. There's a lot of people who helped with the presentation in many ways. There's a lot of people who are working on the Causality benchmark data repository as well. So yeah, thank you guys. So let's see what is going to be today. I'll speak a bit about our company. Then I'll show you how LLM agents can work with interpreter, Python interpreter in this case. I'll show you a simple demo of a tool we have built. And then I'm going to show you the ideas and the tools that you can put into a single LLM agent to build something for your own use case. So we are a team of quant finance professionals, physicists with backgrounds in data science, artificial intelligence. We have a long live trading track record. We're trading on our proprietary capital since 6 years now. We have established a credible track record. And we have built a very unique blend of strategies that is not correlated, not similar to other investment strategies. Everything we do is in-house based on our ideas about machine learning. Much of the ideas are domain-driven. And then on the top of those domain-driven ideas, we are applying machine learning algorithms to forecast. And also we're using large language models in these machine learning workflows. Okay, so everyone today have seen ChatGPT, have seen LLMs can operate as an oracle, knowing things. So you ask a question, they give you an answer immediately, just based on the connections of the neural network behind. Now, that was the thing that changed the world last year. What is changing the world this year, I would say, is LLM agents who have various capabilities connected to the GPT agents behind, or the large language models behind. And one of those things can be an interpreter. But how do you connect tools to an LLM? So here's a simple example. If you just use an LLM, LLMs are initially trained for large corpus of data. So they will be very good at predicting the next token in text that they have found on the internet. Now, such an LLM, which is able to tell you the next token or the next word or the next character in a text, is already very smart. So it has to know the context. It has to have a common understanding of what's going on behind in the semantics of this sentence. But it won't really do what you want it to do. So what people do is that they take these pre-trained transformers. That's why it's called GPT, generative pre-trained transformers. So you have this very expensive pre-training process. And after that, you can slightly modify the behavior with fine-tuning. So what they do is that they teach these large language models and a lot of data, and then they teach they modify their behavior slightly to answer your questions, to really do what you would like to do. So you have a fine-tuning data set for that. And in that process, what you can also do is to teach it that, well, if they are asking you something that you don't know, or is recent data, or it requires mathematical calculation, then just ask for help. And this is an example for that. So function calling is achieved by fine-tuning of the LLM. You can either fine-tune, or you can also tell the LLM that in this situation, you have to use external tools. So what happens here? In the first line, you see that the user is asking a question. And instead of telling that the president is whoever was the president at the time of training this LLM, the LLM answers search, the special word search with its argument. And then the execution environment actually goes to Google or whatever search engine, search for these terms, summarizes the results, feeds it back to the LLM, and then the LLM, based on that external information, is able to answer you correctly to the question. So this Joe Biden is not coming from the knowledge of the LLM, it's coming from the tool that it has used with function calling. Same example with mathematical operations. Calculators are much better at maths than LLMs themselves. So when an LLM sees that, well, this particular LLM sees that, okay, I'm not going to be very good at this task. So it's going to call for the calculator function. It completely copies the mathematical expression that has to be calculated. The calculator puts back that answer to the context of the LLM, and then the LLM can answer. So this is basic function calling, and most of the useful LLMs on the internet, they are doing some form of function calling. Maybe they can search a database, maybe they can buy you tickets. But this is a really good idea if you have a very specific use case and you want to use it for that. But what we want is a pretty generic use case. I want my LLM, at least theoretically, to do anything. And how you do that? So here's an example. This LLM that I'm using and this agent framework, when you ask it, what is the square root of a complex operation, then instead of calling calculator, it is calling the only tool that it knows, which is a Python interpreter. So we're using function calling to a Python interpreter with this string inside. So it imports a library, it calculates a result, and it prints this result. And this is the power of using Python as your function to be called, because these LLMs, they know how to program. So they can program up anything. They can program up actually calculating something. They can they can import a Google search library and immediately go to search for Google. And they can also help you doing your quantitative research. So that's what we will check later. Here's another example. Here I'm asking, what is the current time? So it doesn't have a clock built in, so it cannot, there's no function for knowing the time. But it just goes for the Python interpreter, executes this code, and then the code tells it what is the current time, and then based on that, it can answer to us. So this is really the power of having an interpreter in your LLM. It becomes a bit like a neurosymbolic system that whatever requires intuition, the LLM will take care of, and whatever requires solid symbolic calculations, that will be taken care of the Python interpreter. So what happens if you have an error while executing the Python code? We'll see an example for that here. So let's say you, the user, you tell the LLM, okay, I want a plot of Meta and Tesla. And the LLM says, okay, I think this is going to be the code. But then the environment executes it, and what if it doesn't work? You get whatever kind of exception. Now, normally you would actually ask it again, like, hey, this didn't work, I got this error, what should I do? But in this case, it's the environment automatically feeding back the errors. So the LLM can automatically respond that, okay, first we have to install, in this case, this library. And after installing, it starts to work. And this way, the LLM already learns how to do certain things from interaction. Often if you go to ChatGPT and let's say you use it for coding, you ask a code, makes a small mistake, you copy it to your environment, it doesn't work. And you're like, wow, this is not so smart. But then if you actually immediately feed it back, not yourself, but the machine feeds it back to the LLM from the type of the exception in a big percentage of the cases, it will understand, okay, I kind of made this mistake. Let me try again. So it will iteratively find the correct program code. So this is really the setup. It's going to contain two agents. We will have a user proxy agent. You can see that it has these two capabilities. One is that it can ask you for input. The other is that it can execute any code in Python. And then this will be connected to our actual agent with the large language model inside. So this is really the base setup, but what we are going to modify to make it very helpful for research is so in the previous setup, this user proxy agent would start with a Python interpreter every time it gets a program. So these are independent executions of the Python interpreter. What we do, based on an example, we modify this user proxy agent, override the class. And in this run code function, instead of starting a new Python interpreter, we're using the IPython, which is the IPython on the notebook where we are actually executing the LLM at. You can see that in the constructor, we're actually taking the actual IPython kernel that we are using. And here we are executing the code as a cell in that environment. We take the logs and we feed it back to the LLM so that it can see what was the error, did it work, what were the printouts of its own code. So this is the basic framework. I'm going to show you the demo that I don't know if you have seen already on the internet. You can check us on LinkedIn, by the way, so you will find material about the company and also about this special demo that we have built. So I'm going to show you this demo, and after the demo, I'm going to show you tools that you can use to build your own LLM agent. I want to show you a demo of a technology we use. This technology is an LLM agent. It is called Max. We are using a code-first LLM agent framework, and I have already taught Max how to use our data library, the Causality open source repository. You can see the result of the analysis I'm asking it to do. I asked it to go to Google Scholar, download a peer-reviewed publication, summarize the results, get the ideas from it, and implement some trading signals based on those ideas. Let me erase the whole notebook. I'm going to execute it. And while it is running, I'm going to explain you everything that happens. In the first cell, I'm importing Max, and I'm importing the Causality open source library. It has a data loader, and it has a signal backtester function. I already explained Max earlier what is the signature, documentation, and operation of these functions. Here I'm defining helper functions and storage variables that both Max and I can use in the same namespace in the notebook. So in some way, we are going to work together on the same notebook. This is the first task I'm giving Max. Go to Google Scholar, get the short-term momentum article, and download the PDF. It goes and it does it. Next, I'm asking it to display the article on screen so that we can speak about it. The article states that assets with low turnover, they display reversion, while assets with high turnover, they will display momentum. Once we have the article, now I'm asking Max to get data from disk using the Causality open source library. I'm asking it to get overnight returns, the trading universe, and turnover. I'm asking it to save it in a dictionary. As you can see, this has executed properly because in the next line, I'm able to use that data, which is in the dictionary. Once all the data and returns are already in memory, now I can go ahead and ask Max to really do the job I wanted to do. I wanted to code up some trading signals. Here are some examples of how I usually code up trading signals. I like to only generate the trading signal over the universe. I like to do some normalizations. So I expect all the alpha signals to look like this. I ask Max to implement a similar idea to the articles based on the summary it already has. You can see that it saves it in the dictionary because the keys, these two keys, are on the dictionary already. So what did it do? This is a different operation for Max. I'm just asking it a question. It's not going to really do anything. I asked it what was the code that you have just written, and this is really the code for generating the alpha factors. It takes the 10% lowest return assets, top 10% highest return assets, same for turnover, and then at this stage, it generates the high turnover momentum alpha, high return minus low return multiplied by the high turnover mask. And here it takes the opposite for low turnover assets. It creates a reversion factor. Now I'm asking it to run a backtest. It already knows how to use the given function in the open source library, to run the backtest. And here I chose to visualize myself using my own piece of code. And there we can see that one of the ideas, the low turnover reversion idea, that kind of still worked until 2020, not so much afterwards, while the other idea is actually not operational, is not true anymore in this backtesting period. What do you think about this? Where is this technology going to develop?
All right, so let's get into what goes into such a system. In the demo, I've been hiding a lot of details of how the whole backend works behind the system. But now I would like to speak about the possibilities of how to easily customize a similar LLM agent and what goes into the design. So if you would like to build your own LLM agent, the first thing would be where to start. I mean, you can code it up yourself. You can connect to an LLM directly, but it's actually much easier to go with an already existing LLM framework with existing tools in the library. I consider these 4 frameworks: AutoGen, TaskWeaver, LangGraph, and CrewAI. Each of them have very unique benefits. You can see on the top right table. Basically, the 2 that have very good traction is AutoGen and CrewAI. They are growing really fast. CrewAI is successful because the person who writes it, he's constantly coming out with new ideas and it's growing really fast. And AutoGen is really successful because it's the first one that ever started. It's made by Microsoft, so it has a lot of backing. Now, out of these 2, AutoGen was my favorite because it's actually a coding-related framework where the Python interpreter is by design in the system. CrewAI, you can connect to a Python interpreter, but it's not really designed for this. My other favorite was, I had 2 other favorites. LangGraph I like because it's built on the top of LangChain, which is the largest and oldest orchestration environment for LLM frameworks. For some reason, despite they are the biggest, LangGraph is not growing as you would expect. They have now a paying model that may be part of the reason, but you can see that despite it's a very old framework with a lot of backing, it's not becoming very popular. And then TaskWeaver would have been also great. You can see that Microsoft has 2 frameworks, which already shows how important agents are becoming this year. So actually Microsoft has more, there's for user interactions and there's more agent frameworks that they are releasing. These 2 are for coding.
If you want something simple, just trying an agent and not really program a lot, not modify it, then I recommend you Taskweaver. It has a nice graphical interface. It has planning. It has reflection built in. And it can immediately do quantitative research for you. I have chosen AutoGen because I want to modify it. And AutoGen is a large framework with good documentation. It has its own website, not just the GitHub website, but Microsoft website with a ton of examples. And I'm pretty glad that I chose AutoGen because I found really nice tools in these examples to build our own framework. Okay, so we will look at these 4 customizations of an LLM. There are very simple ways to make your LLM aware of how to use your tools, and there are more tricky ones which are reading from external documents, or they are using offline or online memory, as you will see. So let's start with the system message method. This is kind of the easiest. So when you're creating an LLM agent programmatically, you see it in the bottom right, you can provide a description and a system message. Now, typically, there's a standard system message that you are a helpful AI assistant with some guidance about how to serve a user. But you can use the system message for much more complicated things. So in this case, in the system message, I'm explaining the LLM agent that you can actually execute Python code. So you're not just speaking to a user. The code that you suggest will be executed in an interpreter. And I'm also explaining that this interpreter is actually an IPython kernel, so the variables will remain. You're not going to start a new kernel every time. So we're explaining how to use the execution framework itself. And then I'm using the second part of the system prompt to explain the causality benchmark data library, where the data remains, what functions it can already import, or what functions are already imported. So I can give it a lot of context. And after this, if I ask it like, read up a certain piece of data, it will have the intuition to know like, oh, okay, I have to use the load field df function. It sees the whole signature of the function with the docstring, so it can pretty well estimate how to use it. First time it may fail, and then the Python interpreter will tell it like, you're using the wrong path, or you made small mistakes. We'll go back to fix it, try it again. And next time it will know because it will be on the context already. So this is the simplest and very efficient way to make your LLM aware of a static context of what you want it to do always. Now, how do you collect all that information that you want to put on the context? So what I did is to use reflection. I started with a notebook. In this example, I wanted to teach it how to access Parquet files of the same data set. So I explained some things in a long notebook. We've been using various use cases of do this with the data, do that with the data. So after the whole notebook executed, I asked it to reflect. So at that point, like maybe 10 cells with various experiments, exceptions, failures, retries, were already on the context of the LLM. And then I asked it to reflect on the sequence that we have just been doing, create a recipe, include all steps, suggest well-documented functions, generalized Python functions to perform similar tasks in the future. So I just asked it to write up everything that you have just learned today in this particular notebook. On the bottom right, you can see the result of that. I'm printing it in Markdown, but really it's just text that it gave. So it explains everything that it has seen that we have been doing. It includes the useful pieces of program code that we have been using. And that way, if I take this block of code in the right of the screen and I put it on the system prompt, or I put it in a database where it can load it from, next time I'm asking to work with Parquet files of our data set, it will load up all this to the context, and then it can work with it. So this reflection is a very, very powerful way of learning from interaction for the agent itself. So what I have been speaking about so far, everything was happening through the system prompt and through the short-term memory of the system. I would like to speak about how to access external data based on similarities. This technique is called Retrieval Augmented Generation, RAG for short. RAG operates based on a vector database. The vector database contains pieces of text, pieces of textual information, and a vector representation of the kind of information in the database. The whole workflow goes by user asking a question, then the vector database retrieval part looks for pieces of text that are similar to what the question is asking in the vector space, retrieves pieces of relevant information, and then augments the existing text. So takes the user question, and at the end of the user question, it will tell, here's some additional information to answer the user question. It puts there the relevant information. So it has an enriched question, and the LLM can, based on the enriched question, already can answer you with an easy-to-read text, at which LLMs are actually very good. You can imagine a vector database based on a picture on the right. In this example, there are words, but usually in vector databases, you have full documents. You can have chunks of a large document. Maybe there's, let's say you have 1 million tokens in your document to know about. You can chunk it up to 1,000 chunks of length of 1,000 tokens. And each of those chunks, they will have a vector representation. That can have like maybe 1,000 dimensions, the vector representation. But it's very easy to search for similarities in this semantic vector. Basically, the magic is that you are actually using an LLM, another LLM usually, to create this semantical embedding of the meaning of a document. And you're searching similarities in this semantical vector space. And that is really what a vector database is. I'm going to show you a few examples going forward. So this is an agent which is designed to access external documents. You can see the docs path argument in the retrieve config argument. You can see the docs path field, which contains markdown files and documents that this RAG agent has to process. You can see there is this field, the chunk token size, which says that every chunk that will be embedded to the semantical embedding space will have 2,000 tokens. And that you can see that it's using ChromaDB, which is a vector database. You can also see the name of the LLM that is used for the embedding, to calculate the internal embeddings of this LLM based on the semantical content of this document. So this is a very simple example. If you ask, if you build a system with this retrieve user proxy agent and you put an LLM in it, anytime you ask something from the retrieve user proxy agent, it will augment your question with relevant information from this documentation. So the LLM can answer you with a lot of relevant information. The big benefit is that there's two big benefits. One is that it will know things it didn't know before. And the other is that it will not really hallucinate. So hallucination is a thing when it doesn't know what to say, it will tell you some random content. But if it actually sees the documentation, it's very good at copying the relevant part of the documentation to your question. So this is a simple RAG system. I'm going to show you another example with using RAG. So other than using RAG on an Excel document, you can use RAG on the conversation history. So let's see how the conversation history works in AutoGen. I'm showing you 3 prompts. The first one just gives some information to the LLM. It tells it, yeah, I've been in London last week. By the way, the important part is this clear history equals true. This instructs the user proxy to erase the history before this question. So we're starting with a clean slate. There is no history. In the second question, I'm not asking to erase the history. So in the second prompt, where I'm actually asking about what I did in London last week, it will remember because the user proxy agent maintains the conversation history. And from the conversation history, it can answer this question. Now, what happens if I say clear history true with the same question? Obviously, it's not going to know the answer. So we have just erased the conversation history. It's not going to remember to my original statement about London. So this is quite obvious, but I wanted to show you this to show how a retrieval augmented memory would work. You could think about the conversation history as the short-term memory of the agent. The context is limited, the short-term history is limited. Now, a vector database is not really limited, so you can accumulate huge amounts of information there. But let's see how this works there. This feature in AutoGen is called teachability. You can see that on the first lines. We're creating this teachability feature. We're starting with an empty database. We save the vector database somewhere in temp, and we have a recall threshold from this database based on the vector similarities. So let's look at how the same example will work if you have retrieval attached to your agent. So let's start with my initial statement that I met clients in London. What it starts with is that it will check what this statement contains, and it tries to create a question questioning the information in this statement. With that, it's going to save the vector representation of the question in the vector database for later use. In the second example, I'm giving it a completely different statement, which is not really related to the previous one. So let's say, yeah, this week I'm giving a presentation. I'm doing clear history here as well. You can see that as the whole calculation starts, it starts with retrieving information from the past, which is quite far from this information. And then in the second part of the slide, you can see that it's going to remember this information. You can see here that it created a question-answer pair with the current statement. So this will be the second data point in our vector database. And when I'm asking, after erasing the context again, so you can see that clear history is true in this case as well. And I ask it, where did I meet clients? What it will do is that it takes my question, checks the similarities of the semantic vectors for the two elements in the database, one speaking about this presentation, the other one speaking about last week in London. It will find that this one is very similar, so it's very near to the question being asked. And then it will decide, okay, I'm going to read this up, not the other one. I'm going to read this up, and I'm going to append the user question with this postfix. Memories that might help. It will read up my first statement. And then the real question that goes to the LLM agent is, where did I meet with clients? Memories that might help. Last week I met clients in London. Based on this question, obviously the LLM can already answer correctly to the question. So this is a more advanced method to teach your LLM. You can combine this with reflection, and you will get a pretty powerful agent. So this was really the bulk of the presentation. This is the system that we have built. This is really experimental, and we're using it in-house. We're using LLMs in many other workflows in the company. Yeah, it's your time to ask questions.
Impressive, Mark. We have time for questions, of course. You can ask Mark in English or in Spanish. You can open your microphone ask questions or just write on the chat part of the screen. Podéis hacer las preguntas a Mark abriendo el micrófono o directamente escribiendo en el chat y está preparado para responder. ¿Quién rompe el hielo?
Vale, chicos, de verdad, puedo hablar español también. Cualquier duda.
¿Desde cuándo estáis usando esta tecnología?
Hemos aumentado mucho el año pasado.
Ujú.
Sí, es una mezcla de... Al final se puede usarlo en varios puntos en el Machine Learning Workflow para parametrizar el métodos de forecasting, de predicción. Y vale, no puedo decir todo, que no hay un parte de nuestra propiedad intelectual que no puedo hablar.
Sí.
Pero bueno, al final lo que está pasando es que con customizando suficientemente puede ayudar en cualquier proceso. Y como la tecnología está mejorando, queremos tener los partes iniciales para crecer juntos con la tecnología.
Ujú. Muy bien. Preguntas, señores. Edu ha abierto el
Hi,
micrófono.
Mark. Thank you. Hi, thanks for your presentation. My question is regarding the performance. How much has it improved compared to the standard methods using this LLM?
It really depends on the benchmark. I've seen various frameworks with different purposes. Actually, one of the examples in the presentation was about the machine learning framework from Microsoft, and they are using LLMs for parameterizing forecasting methods. It's pretty powerful, but it depends really on the use case. So for first shot inference, that you're just asking it to immediately tell me a reasonable parameterization for this given problem, I think it's pretty good. But the knowledge it has is actually coming from experts on the internet, and in some cases from customization from Microsoft engineers. But there are also other frameworks for optimizing your models. So in that case, I wouldn't say that it's much better. It's just one of the alternatives. In some other use cases, it actually opens doors. So it can also do things that you were not able to do before. In finance, it's very common to use them for sentiment analysis. And that business has changed a lot since ChatGPT came out and the open source models. Earlier, people were buying sentiment from providers who were fitting the LLMs. These days, people are much more likely to buy data and build their own LLM for the sentiment analysis that they want to. So it really depends on the kind of benchmark you're asking about.
Okay, thanks.
Más preguntas.
All right, if there's not many questions, that means my explanation was relatively clear. I mean, feel free to contact me anyway on any platform. I didn't put my email here, but you can find me on LinkedIn. And I'm very glad to help you with whatever question you have about the presentation, or if you start your own system. I'm really glad to have some chat.
Perfect. I'm gonna stop the recording.